Assalamu alaikum. Today I have an introductory lecture about the molecular spectra, and this is the chapter 4 of our syllabus. You know that we have two types of spectrum. One is called absorption spectrum, and the other is called emission spectrum. And the spectrum is further divided into two types. One is called continuous spectrum, and the other is called discrete spectrum. So this is a continuous spectrum. So you see that the wavelengths are continuously distributed and there is no gap between the wavelength. However, if you look into the discrete spectrum, so there is a gap between the two color. So these colors are actually wavelengths. Again, you see here the color. So these two are the discrete spectrum, and this one is the continuous spectrum. This is emitted by the atom, and this one is emitted by a molecule. That is why the discrete spectrum are further divided into two categories. One is called the line spectrum, and this is generally emitted from atom. And this one you see here, this is the single line. These are the single line. That is why this is called a line spectrum. And the other is the band spectrum. So this is emitted from the molecule. So here you see there, this is one band. This is a band of wavelengths. This is a combination of the wavelengths. You see here just only one green line. And here you have multiple green line, so you have a band. Similarly, you see here you have a green band, here you have a yellow band. So this is the type of molecular spectra. So in this chapter we will mostly talk about this spectrum, which is called the band spectrum. So the main difference between the atomic spectrum and molecular spectrum, the atomic spectrum is the line spectrum and the molecular spectrum is the band spectrum. Why we have the band spectrum for molecules? Because it consists of three contributions. One contribution is from the rotational transition, another contribution is from the vibrational transition, and another contribution is from the electronic transition. Okay, formation of the molecular spectra could be explained on the basis of the molecular energy state. And of course, these energy states are the quantized. So in molecules, we have three types of the energy state. One is associated with the rotational energy state, and these are formed as a result of rotation of the molecule about its center of mass. We have the vibrational energy state, and these states are obtained as a result of the vibration of the constituent atom relative to one another. And we have the electronic energy state, and these energy states are actually rise because of the configuration of the electron in different molecular orbitals. So a molecular spectra is obtained actually because of the transition from one of these energy state to the other energy state is governed by the selection rule. So not all transitions are allowed, only those transitions are allowed which are allowed by the selection rules. So we have different selection rules for the rotational transition, we have different selection rules for vibrational transition, and we have different selection rules for the electronic transition. So the molecular spectra actually give us information about the structure of the molecule. It gives us information about the bond length, the bond strength, and the bond angle. So rotational spectra. So the rotational spectra actually arises because of the transition between the rotational energy state. So the rotational energy state are separated by a very small interval. This is of the order of milli electron volt, and the rotational spectra arises from the transition between these states, and we have the rotational spectra in the region of microwave of the wavelength between 0.1 millimeter to 1 centimeter. So here are the energy, the rotational energy levels. So they are discrete. J is the rotational quantum number. So for J is equal to 0, you have this energy. For J is equal to 1, you have this energy. For J is equal to 2, you have the, and so on. So the general rotational energy is equal to E is equal to J into J plus 1 B. B is the unit of the rotational energy. So here we have the two atoms. So of mass m1, m2, they are interconnected and they are rotating about this center of mass with different energy. So it depends upon their speed of rotation, or you can say it depends upon the angular velocity. If the angular velocity is higher, so the rotational energy is higher, and if the angular velocity is lower, so rotational energy is lower. So just like an atom, we have the discrete energy state for the electron. So here in molecule, the molecule can only rotate with discrete energy levels. This one is allowed, this one is allowed, this one is allowed, and no energy between these two energy level is allowed. You can think about this like you have a ceiling fan and you have uh, connected that thing with a regulator. So in that regulator, you have different speed 1, 2, 3, 4, and 5. So you can adjust the ceiling fan with different speed. For example, at 1, it could be moving with very high speed, and then you go to 2, 3, and 4. So you are going decreasing its speed, or you can increasing the speed. So there is a discrete increase and decrease in the speed, rotational speed of the fan. So this corresponds to the different energy levels. And rotational spectra is a can between the transition. For example, if the molecule is read from J is equal to 0 to J is equal to 3, so you will have an absorption spectrum. And if the molecule come down from J is equal to 3 to J is equal to 2, so you will have an emission spectrum. So that in this way, you will have a rotational spectra of the molecule. So here is a water molecule, and you can see its rotation. So if it speeds up, so it will go to the higher rotational energy speed, and if its speed go down, so it will go to the lower energy state. And the rotational energy level, of course, it depends upon the temperature. So the temperature is higher, so the rotational speed is higher, and the molecule is in the higher rotational energy state. We have the vibrational spectrum, and the vibrational spectra arises due to transition between the vibrational energy state. And the vibrational energy state are separated with somewhat larger interval, that is of the order 0.1 electron volt, and the vibrational spectra occur in the infrared region with the wavelength 10 to the power 4 angstrom to 0.1 millimeter. And here we have the different energy level for the for the vibrational energy state of a molecule. So the vibrational energy state of the molecule behave like the potential energy of the mass attached to a string. So we have exactly the same energy pattern like that of the simple harmonic oscillator. So here N here is the vibrational quantum number, and the energy of the molecule in its vibrational state is nth vibrational state is equal to n and plus 1 squared omega. So if you are putting n is equal to 0, so you are here. When you n is equal to 1, so you are here. So in just putting different value of n, you are going up in the vibrational energy states. And of course, when there is transition from the higher vibrational state to the lower vibrational state, so there will be emission of the vibrational spectrum. So here you see the water molecule. So this is H2O, so this is oxygen, and this is the two hydrogen atom, and this hydrogen atom is vibrating in this direction, and this hydrogen atom is vibrating in this direction. And depending upon the speed of the vibration and also the amplitude of the vibration, we have different uh, vibrational energy state. Okay, so this must be kept in mind that the vibrational energy level are higher than rotational energy level. So when you are exciting a vibrational energy level, so actually you are exciting many more rotational energy level as well. So whenever there is a transition between the vibrational states, so there is also a transition between the rotational state as well. So that is why the vibrational transition is always carried out along with the rotational transition. In other words, you can say that the vibrational spectra contain the rotational spectra as well. Now we have the electronic spectra, and the electronic spectra is of course obtained as a result of transition between the electronic energy state and the molecular electronic energy state are separated by larger interval which is greater than 0.1 electron volt, and the spectra that arises from the transition between these two, that is in the visible and in the ultraviolet region. So here we have the let's suppose this one is the uh, lower electronic energy level, this one is the upper electronic energy level. So this one electronic level energy level will contain many vibrational transition, and one vibrational transition will contain many rotational transition in the microwave and the vibrational transition in the infrared. So whenever there is an excitation from one electronic state to the another electronic state that is generally carried in the ultraviolet region, so there is a transition or involved between the rotational energy state as well as the vibrational energy state. And when we have a, an electronic spectra, so this electronic spectra consists of contribution from the rotational as well as vibrational transition. So this was an introductory lecture about the molecular spectra. The next lecture will be about the rotational spectra. So in order to explain the rotational spectra, first we have to talk about the rotational energy level. So for the rotational energy level, first we will consider the diatomic molecule, and then we will go to the polyatomic molecule, and then we will go to the rotational spectra. So this is an example of the diatomic molecule. So there is a rotation of the molecule about its center of mass. So for the next lecture, you have to know about the rotational dynamics and the center of mass. So hopefully tonight or tomorrow I will post another video, and that will be related to the rotational energy level of the diatomic molecule. Okay, Allah Hafiz.